Hello all. In this lecture, we will discuss what is black body radiation and ultraviolet catastrophe. Let's start with black body radiation. Any body which is at a constant temperature and is in thermal equilibrium with its surroundings will emit the same amount of energy that it absorbs. An ideal body which can absorb all radiation incident upon it irrespective of the frequency of radiation that falls upon it, that is called a black body. Now, if we consider in the laboratory, how do we visualize or how do we obtain a black body? Take a hollow object with a pinhole on it, and any radiation striking the object and which enters through the pinhole gets reflected by the walls of the black body, by the walls of the hollow object multiple number of times, and finally it gets absorbed. This is the best approximation of a black body which is possible in the laboratory. Now if you examine the radiation that is emitted by a black body, it looks the spectrum from a black body looks something like this. On the y-axis we have plotted energy density of radiation, and on the x-axis is the frequency of radiation emitted by black body. Here you see that there are two graphs plotted. One is for a black body at 1200 Kelvin and the other is for a black body which is at a higher temperature of 1800 Kelvin. We see that a black body which is hotter emits radiation which peaks at higher frequency compared to the radiation emitted by a cooler one. Now, how do we explain the shape of this spectrum that is obtained from black body? Lord Rayleigh and Jeans were examining black body radiation, and they considered black body radiation as standing waves in a cavity. And the number of standing waves in the frequency interval nu and nu plus d nu were calculated to be 8 pi nu square by c cube d nu. The average energy of a standing wave was taken as kT, and so the total energy density in the frequency interval nu and nu plus d nu would be a product of these two, number of standing waves times energy per standing wave, and total energy density u nu d nu is given by this expression which is called Rayleigh-Jeans formula. Now it is in this context that we come across something called the ultraviolet catastrophe, and we will just see as we progress what is ultraviolet catastrophe. We already have a black body spectrum which goes like this. Energy density slowly increases with increase in frequency, peaks at a particular frequency, and then it gradually falls down. Let's see whether Rayleigh-Jeans formula is capable of explaining black body spectrum. This formula is one which gives energy density in terms of frequency. From this expression, we see that energy density increases with frequency and is proportional to nu square. So, when frequency is 0, energy density obviously would be 0. But as frequency increases, energy density increases quite fast as nu square. And in the limit of infinitely high frequencies, energy density should also go to infinity. But we see that this is not the case with black body spectrum. Black body spectrum doesn't go to infinity. It peaks at a certain particular frequency and then it gradually falls down. Whereas This dotted line indicates the shape of blackbody spectrum as predicted by Rayleigh-Jean's formula. So we see that at the low frequency region, Rayleigh-Jean's formula is capable of explaining blackbody spectrum, but as frequency increases in the higher frequency regime, Rayleigh-Jean's formula is incapable of explaining the observed blackbody spectrum. And this discrepancy in the high frequency region between Rayleigh-Jean's formula, between the prediction by Rayleigh-Jean's formula and the observed blackbody spectrum is called ultraviolet catastrophe. Now, where did they go wrong? It was to correct this that Planck proposed that oscillators in the cavity walls cannot have continuous distribution of energies like kT, but instead the energies should be quantized in units of h nu, where h nu is the energy of each discrete bundle called quantum. And light is composed of several such quanta, each of energy h nu. And an oscillator which jumps from a higher energy state to lower energy state would emit radiation of frequency nu, and one which goes from lower to the higher state would absorb frequency of radiation nu. Now that the oscillator energies are quantized as nh nu, the average energy per oscillator would not be kT as taken by Rayleigh-Jeans, but instead it would be h nu by e raised to h nu minus k, h nu by kt minus 1. So this would be the average energy per standing wave. So this multiplied by the number of standing waves would give me an expression for energy density like this. Because if you just remember the expression for number of standing waves, it was 8 pi nu square by c cube d nu. This multiplied by the energy, average energy per standing wave that Planck considered. If we multiply both these expressions, we would get an expression for energy density like this. And this is called Planck's radiation formula. Now, let us examine the success of this formula in explaining blackbody spectrum. At high frequencies, we saw that Rayleigh-Jean's formula was quite incapable of explaining blackbody radiation spectrum. At high frequency regime, we can consider h nu is much greater than kT, and exponential h nu by kT tends to infinity, which means the denominator tends to infinity and 1 by infinity would tend to 0. So u nu d nu would go to 0 in the high frequency regime. So there is no more ultraviolet catastrophe. And in the low frequency region, Rayleigh-Jean's formula was a good approximation to blackbody spectrum, and in the low frequency region we can take h nu is much less than kT. So h nu by kT would be much less than 1. We all know that for in general e raised to x can be written like this, and when x is extremely small we needn't take the higher order terms like x square, x cube, etc., and e raised to x can be approximated as 1 plus x. So e raised to h nu by kt can be approximated as 1 plus h nu by kt. So this term would be like this, and 1 and 1 cancels and you would get 8 kt by h nu. In the regime h nu much less than kt, or the low frequency regime. Now at low frequency regime, thus Planck's formula would become 8 pi h nu cube by c cube times kt by h nu, and this would give me 8 pi kt by c cube nu square d nu, which is nothing but Rayleigh-Jean's formula. So we see that the concept of quantization has rectified the problem of ultraviolet catastrophe. and black body spectrum could be clearly explained by Planck radiation law. Thank you.